Want to nail engineering manager interviews at Mang and other top-tier companies? You can with USA's #1 tech interview prep platform. We have 300 plus SMEs and instructors from top-tier tech companies to help you land your dream job. We've helped thousands of engineers make their way into Mang. You could be next. To learn more, register for our free webinar.
Hello?
Oh, hello.
Could you share your screen?
Sure.
Do you have any interview come up soon? What's your situation right now?
Yes.
So what's your background?
Currently, I'm the director of engineering. I've been working for about 8 years now. Prior to that, I've been working on video processing systems.
I see. For the team you interview with, what team you are interview with?
I'm yet to do a team matching.
What's the position you are interview with?
EM, engineering manager.
Okay. I see. So you have your background is in mobile development.
Yeah.
So mobile, mostly it's Android or iPhone.
iPhone.
Okay. So your company designed the iPhone app?
My company is a marketing company, so we build websites for radio and TV, and then we design apps for them too.
Video and the TV. Okay. Media. Okay.
Yeah, media.
I see. So then you have a client side, even media data. Then you also have server side, also have data. You're using both cloud, AWS and Azure cloud, both.
Oh, I'm sorry. I mean Aurora, not Azure.
Okay. Okay. Then you have Aurora, you have EC2 S3. How much data in S3? How many terabyte data in S3?
I think we have 40 terabytes.
Okay. How many inside Aurora, MySQL?
Aurora, it doesn't give you a number, but I think it should
How many
be
instances?
Instances? 4.
4 instance. What's the instance? R3X large, 4X large?
It's R4X large.
R4, 4X large. Okay. So you have this, you have video data. How many iPhone client talk to server per second?
Okay, so our request rate is about, I'll say on the peak, it's about 3,000 per second.
Okay. Average case?
Average case, I'll say 1,000.
Average. How about the idle case, minimum?
Low peak, 200, 300. That's at midnight.
Okay. I see this. What's your team size?
I have 2 teams, 6 on each side, so total of 12.
Okay.
6 WordPress developers, 6 mobile apps.
What's the difference?
So the backend for the mobile app is a WordPress system for loading the content for the news and uploading the videos, and then the mobile app.
There are 2 teams. One is the mobile app, another team
CMS.
It's a blog.
Yeah, it's a blog. Yeah.
Okay. So the 2 teams doing this. This is under your site. How about your VP? Under VP, how many people? Your boss, under your boss.
Right. There are 2 people above me, COO and CEO.
Okay. So how many people repeated this CTO? You repeat your boss. How many people in your manager or manager? How many people?
My manager manages 3 people. That's me, customer service, head of, and then release, head of release, website release manager. Yeah.
I see. Your basically your core engineering team. Okay. understand this whole architecture, whole things. So which Google product you interest? If you do team match, which one you prefer?
I'm interested in the Google Home team and also on parts of the search team.
Okay, how many team in Google do you know? High level?
0.
They're doing something related to advertise. More than 2/3 people that are doing advertise.
Okay.
Yeah. There's all different team.
It's a lot of teams. I think I'll be interested in YouTube, Play Store, and Home.
Yeah. Okay. Okay. Understand this. Play Store. Okay. Let's try to do this. How do we upload? Let's say in the Play Store, I want to update software, push new release. How do you design a system, push new release to any application app?
Okay. Let me ask you a quick question though.
Yeah.
The guys that I'll be speaking with tomorrow, are they just random from any team?
Random from any team, yeah. It could be random, yeah. Could be related to some project. Any team, they come from any team, they could be asking you some question related to their team. I have no idea where team they come from. If people come from search, but you don't have background search, they may not ask you search questions. So yeah, any person should match in your background. So based on your background, if based on how lucky you are, some people based on I'm from no matter which team I'm come from, based on your background, try to ask a question related to your background. At least you did something before. So their main goal, at least during 45 minutes, find out what you good at. Not finding out what you don't know. You need to find out what you know. Yeah, same thing for you. Your goal to show them what I know in 45 minutes. If you ask you something, nothing, you don't know anything about, you say, I don't know this area, please change the topic.
Okay.
Yeah, your goal, you want to show you, I'm good at this. Any team needs this person that have this skill. You have so many teams. So my skill can fit in the YouTube. My skill can fit in the Google Play Store. My skill can fit in the Nest. You try to introduction to bring some keyword related to Play Store, related to YouTube, related to Nest. They show you some interest. They based on your introduction, they try to find a problem match your background.
Okay.
Or they give you generic problem.
Right.
Also possible. Yeah, if you give generic problem, for example, maybe find auto suggestion, design auto suggestion for YouTube. You can write down the problem, design auto suggestion for YouTube. Return top 10 suggestions. Okay, I can list a few problems. You can pick one you can interesting.
Okay.
Second problem, Play Store. I want to update new software for Play Store. How do I push new software to Play Store? Same thing, I have Chromebook. How do I update new software for Chromebook? New release for Chromebook. Or any Nest device. I need to update software for Nest device. Because I need to update software. This is for many teams need these people have these skills. Okay. For YouTube, maybe we can try to compete with TikTok. How do you design maybe 10 minutes video, short video, dashboard, maybe just the infinities just scroll up and down.
With voting up
just
and
rolling
down.
up and rolling down with a short video. People can watch the video, then pause, then continue next video. Every video very short, only 10 minutes or 3 minutes short video. Okay. For main servers, all the servers, Google Suite, how to design Google Drive, we don't want interesting. Design Google Doc, not interesting. Or design advertise. How do you design advertise Exchange server?
Yeah, I have no experience in that.
Yeah, at Exchange. Then
So
a cloud.
I
Maybe how do I in my cloud? I have 1 mini machine in my cloud. How do I design a monitor server for my cloud? Cloud monitor service. Detect
that would
healthy
be,
of each machine.
so that's okay.
Yeah. I design healthy of each machines. Therefore, everything have different problem, right? Google Suite don't care. Then Google Cloud have many teams. Then Cloud have storage. Google also have database. They provide the cloud database service for user. Maybe I Google Cloud recently called Alloy database release can how to make Alloy database more friendly, scale up Alloy DB, scale up Alloy DB. Maybe try to find a feature Alloy DB to implement. They have new database called ALLOY, ALLOY, Alloy.
Oh,
Yeah.
Alloy.
Alloy DB. Yeah.
Oh, okay.
This is called Alloy DB.
By Google.
Scale this. Yeah. This is MySQL, just like the Postgres. This implements Postgres. Yeah. There's a Postgres SQL.
Okay.
So what database did you use in the past?
I've used MongoDB, MySQL,
Okay.
Aurora.
Okay.
But not,
Yeah. Alloy
not
DB just like Aurora MySQL, Aurora Postgres. Same thing as Aurora Postgres.
Gotcha. Okay. It's this. They all scale the same.
Yeah.
No sharding.
Yeah. Okay. This is a different problem. You can pick anyone to solve it.
Okay. Can I give you a kind of a walkthrough to each of these problems?
Yeah. It's fine too. Yeah. Give a key idea for each problem is fine too. Yeah.
Yeah. Okay. So for the push news service, it looks like they are all the same. First of all, I think we're gonna need we're gonna need like a microservice to upload the update, right? Upload and manage the update, and then we're going to need another service to distribute, right?
Yeah.
The update. So for the distribute update, we're gonna distribute a geolocation.
Yeah.
And this is gonna be with the API. Will be only read,
Yeah.
read API.
Yeah.
And the upload service we can save with a blob or object database. I don't know if we should cache. Perhaps we can use a CDN to cache the
cache the data.
The data across geolocations. And I think that's it. There's probably some key value stores, but for the KV stores, we can use a pops up to replicate the KV across data centers.
Yeah.
Right. Okay.
Also, for this, you need a schedule for update. Define maybe 30 days to update. Then first 5 days the update only 5% of device. Then 15% device, 25% device, 45% device, 80% device. So all the updates should be gradually. We cannot one shot.
Oh, okay, gradual. So I need a scheduler service. Right?
Yes. I have planning or schedule. We're testing out the dry run, include the dry run. When pre-review, we include pre-review, dry run, phase 1 release, phase 2 release, phase 3 release. Yeah.
Right. Phase release. Okay, now if I do the planning service, does that mean that the planning service needs to ping to know all the devices available to update?
Oh, don't need a ping. The device once online, the updated information. We need some event to collect the device information. Whenever device talk to Google service, they have a device ID, device version information. This information will be logged. Maybe log this, then put it to Kafka or PubSub tells
Right.
okay, which device belong to which group, how many of them, which one need update, which one don't need update.
Right. Okay.
Yeah, whenever you talk to Google Server know your ID, know your device, know your version. Then just keep track how many active for this device. I know how many I sold, then how many online active online.
Right. So then that means I'm gonna need a write service to log.
Yeah, log this how many active device per type.
Yeah.
What's also for each device, what's their version information? Maybe using 2 years old version.
Right. Right.
Yeah, somehow on 2 years old version, we cannot directly update the latest software. We need to do bridge update. We tell them, okay, schedule update bridge 1, bridge 2, bridge 3, then read the latest.
Right. Yeah. That's true.
Because sometimes you even have new device coming in, they reboot 10 times. They do 3 updates.
Right. Okay.
Okay, this is one topic. The next topic.
Yeah. Okay. Design auto suggestion for YouTube. Okay. So this sounds like a recommender system, right? So there's going to be an online and an offline batch job. I'm thinking of when you visit the YouTube webpage for the first time, it recommends some
Not
videos
use
for you.
with it is a different problem. Basically, search box, you can type any phrase. You type any character that suggests a list of 10 search phrase for you.
Okay. So
for any key step, any key of type is the auto generate, auto suggestion, auto complete.
Okay. So this is a depth problem. It's a specific autocomplete problem.
Yeah, autocomplete.
Right. So I'm just going to need kind of a search autocomplete and service.
Yeah.
And I think the solution is going to be on the algorithm that I'm going to use.
Yeah.
So I can do an inverted index. You know, one of the things I could do, inverted index on all the KVs.
We don't use inverted index. We use in try data structure.
Try, right? Okay.
Yeah, no inverted index.
Yes, that's true. I was thinking of try too.
Yeah, try is a prefix match. We are using prefix match try or Redis try. Another try called Redis try.
Redis, like Redis database try.
Redis, not Redis database.
Oh, Radix, yeah.
Redis try, yeah.
Like that, right? Yeah. Okay. Then that would give you a prefix match. Yes. Okay. Yeah, I think that's the best approach. Yeah.
Yeah, there's a focus on try. The next problem.
Okay. Now, how do you scale a try? Is there a database that can do that, or you have to do?
You can using database. Try have 2 parts. One is in-memory data structure. One is on-disk data structure.
Okay.
On disk, you can database table. Try is a graph, is a tree, right? Basically a tree. You put in the tree in the database, just put each edge in the database. One thing I can put all the edge on database.
Right. So
any tree I can put the edge the database.
Right.
I save all the edge the database. I load to node edge to the memory become tree.
Yeah. Okay. And then I have to scale this across geolocation, right? Because people will be doing the autocomplete.
Replicate. We need to replicate because every search the same try. Just replicate the data to different geo region.
Gotcha. Yeah.
Yeah. We need to replicate the data to different geo region.
Okay. And then also I can design a 10-minute short video up and down. This one has 2 problems. This one is like a global counter for the app vote for the voting. And then I also have for the short videos, I think it's a problem of just storing, upload and deliver and read, video, something like that. So we can have, again, we
Yeah,
can do it.
upload and it could be different problem. So you can narrow down to, okay, we don't want to discuss upload. It's assuming already done.
Okay, upload is
Yeah,
already
if we
done.
just
So,
design upload, it's a different problem.
yeah, okay, so save the video. This would be a KV, key value store, with a CDN for the video, or just a blob storage for the video. Now, by the way, let me ask you a quick question. When I do problems like this, like Netflix, YouTube, when I'm suggesting where I should store my data, should I use like an HDFS and build my own blob scaling system, or just say I'm going to use S3, like an object storage?
Yeah, you can use in S3. Similar to S3 will be fine.
Okay.
Yeah,
right.
similar to S3. Whatever, the object store, similar to S3.
Object.
S3, yeah.
Right. Okay, so I'm going to use an object store. So
Yeah.
I have my object store, and this one will just be a simple scale for the read, and I'll just have to scale for bandwidth and throughput. Because
Yeah.
the videos.
Or if you can narrow down this problem, do you want to focus on read or focus on vote only? Maybe just focus on vote only. 45 minutes. I don't want to talk about read. Just focus on vote only. Nothing
Vote
else.
only.
Just focus on counter only.
Yeah. Okay. So this counter is going to be a distributed counter, and every data center is going to have its own write counter, assuming that the volume is really high. And so I will write local and I'll read global.
Okay.
Yeah. So I'll have a writer at each data center with an aggregator. So the aggregator is going to aggregate at intervals.
Okay.
And then when
maybe
I
I'll
read,
change another problem for you. How about this video called live commenting system, design or live commenting system?
okay,
design
so for live
commenting system.
Yes. Okay, so this is also similar to the Facebook Live commenting system. I actually read their system on that. They also write local and read global. So whenever you view a couple of posts, they'll create two microservices. So let's say viewer ship microservice, and then the commenting microservice, and then I'll say the messaging microservice. So this, when you view a post, create KV of the user viewed, and then maybe the server that they viewed on, assuming there's a socket connection to that. And then when we have a new comment or new comment, we will pop sub to the messaging service, and then the messaging service is going to collect information from the viewership, and for each user in viewership that is looking at the content, we'll find out the comment. So we will use, when the post ID comes in for post ID, we'll use post ID. So whenever we get a comment for a specific post ID, we'll check which people are viewing that post comment, and then we'll send an update to each of them. So this logic will be done at the at each data center, and then so the comments will be saved locally at each data center, and then if we hit the read get comments, assuming for a post, it's going to send the API. We'll use API parallelism to query all aggregators of the data center. from all data centers. Does that sound like a good approach?
Yeah.
Okay. So can I move forward?
Yeah.
Okay, so the ad exchange server, this one, I do not have any background on that. I don't even know where to start from.
How about change the stock exchange server?
Stock exchange.
Yeah, change ad to stock.
Okay, so what does the stock exchange server do? Like, it just posts the updates on the price of a stock, right? Is that?
You buy and seller just exchange.
Oh, okay.
Some people buy stock, some people sell stock exchange. Yeah, just matching, find a buy and the seller matching, then exchange. Then make a connection. Yeah.
Exchange. So I'm thinking that to buy a stock, it's gonna be, it's just gonna be a KB store. To sell a stock, you can float the stock, all right? So you put a record, it's gonna be a KB store. Okay,
It's a request, all different requests. Some buy requests and sell requests come in. Then match the requests.
Right.
Yeah, you have queue, could be pub sub queue. Some queue has buy requests coming, some is sell requests. Then need to match different queue.
Oh, okay, yeah, okay. Sell queue, and buy queue, but this queue is going to be very large.
Yeah.
So the problem will be to scale the queue, right?
Then find the match. Then take out one item, find the queue, another item, find the queue, then match. If you match, meet all the requirements, then set a transaction. Okay, log down. Okay, this transaction is start.
Okay. And so I have to come up with the algorithm to find the match, right? I can use
find a match.
I can use a 2-pointer.
Yeah, the buy has a profile. Buy stock has a profile. Have request also a profile. Some requirements. I want to sell whole or sell market price. So I buy the market price. I buy at a certain price.
So I cannot use a query, right? That would be too much queries. For example, I query, I get a sell, and then
you can query. It's fine. Some Kafka queue support query. You can query inside the queue too.
For matching profiles.
Yeah.
Okay. Okay, so I can say possible query.
Yeah.
Okay, and exchange. So exchange is the same thing, right? I just need to find two matching profiles and exchange.
Exchange we process the match. Just process each match. Once you find a match, we process the match. Find a match, then process. Settle the transaction. Yeah.
Okay. So monitor server in my cloud to check health of machine. So I think this one is going to be something similar to CloudFront. No. CloudWatch, right? So we're just collecting metrics from all the servers.
Yeah, for each server, we need to collect. Yeah.
Yeah. Okay. So what I need is I'm gonna just need one monitor service.
Not one monitor service. The scale based on number of server. If 1 million server, you need how many monitor do you need?
Yes.
If my data center have 1 million server, maybe my data center have 10 million server. What do you do? How do you monitor the 10 million server?
Yeah, so I have 10 million servers.
This is 10,000 add 3 more 0.
Okay.
3 more 0. This many servers. 3 more 0. 1 extra 0.
I'll have them pops up. Okay, so I have many data centers, right?
This is one data center like this.
Just
total
one
maybe
data center.
100 data center. Have 10 million server per data center. Have 100 data center. I need to monitor every single machine.
Okay, so at every data center, I'm gonna do this. I'm gonna pop sub, and then it's gonna go to my scalable monitor service, monitor microservice. In the monitor microservice, I'm gonna have my compute aggregator. Okay, so I'm gonna make the pop sub. Actually, the pop sub is gonna send me the information at per second intervals. Right, so it's gonna collect all the information, batch it, and give me a batch every second. And in my monitor microservice, I'm gonna compute first to get some live data. So let's say for the last 24 hours, we are checking for the health, right, of the machine. So I want to know within the last 5 minutes if the machine has been up. Is that a reasonable expectation, right? If the machine has been healthy within the last 5 minutes. If that's the case, then I'll use the 5-minute ring buffer. I'll use a 5-minute ring buffer. And then, I'll bucket per minute. And every minute, each minute, I'll check if, how do I know if this something is wrong? I'll need to check it against a certain metric. So each minute I'll check, for example, if CPU is greater than 60%, or let's say 80%. Okay, so each minute I'll check if, if average CPU is greater than 80%, then I'll trigger alarm. Right, so I can use a memory, I can have a cache on my microservice. My microservice will have an app tier, right? And then a cache. The problem is going to be the scale on the cache, because I'm going to be using an in-memory cache to keep track of my ring buffer. So the write throughput is going to be really high. And so I'm going to have to scale the cache. And I'm going to do that by sharding the cache based on the metric that I'll be using. So I'm interested in CPU, so shard based on CPU metric. Oh, is that right? Now, if I shard based on CPU, then all the metrics are going to end up in one shard. Server ID. Okay, so I'll shard based on server ID. What's going to happen is it's going to split the CPU metrics to all the servers. And I'll have to do a scatter and gather the metric. So it will give me a high throughput on my write, because all the servers are writing to different shards for their matrices. But then when I read it, I'm going to do some work to read it, which is fine, because it's only a ring buffer for 5 minutes. So there's not going to be a lot of reference.
Okay. Next one. That's good.
Okay. All right. So scale Alloy DB.
Basically, scale the MySQL. That's the same thing as scale MySQL. Yeah.
Okay, so scale MySQL.
MySQL is a single write. How do I make this MySQL write through? For example, Aurora MySQL is 100K write per second. Right now, I need to do 1 million write per second. How do I do it?
Right. So currently, MySQL is using a transaction log to commit. So if you write too fast, you're gonna have a lag. If you wanna And then there's also log contention.
Yeah,
Contention
my
problem
SQL is
in the
100K write per second. I want to be 10 times faster. How do I do that?
okay, you have to shard it, right? So we're going to use a hash. We're going to use consistent hashing to shard this. We'll make sure that every insert or update to a specific key goes to a certain cluster. I mean, it goes to a certain shard, right? And then we can also have replicates on the shards.
Okay, you can sharding based on primary key, hashing by
Okay.
primary key.
Okay, yeah, shard based on primary key. Or
Okay.
any, yeah, we shard based on the primary key. And then I can calculate the number of throughput that was given to estimate the number of servers that I need or the number of shards.
Okay. Yeah, maybe have two tables, have two different primary keys. The sharding, after sharding the data sitting in the different shard. How do I run join query in two table?
Oh yeah. So for the joins, so it's almost you have to do a scatter gather for the join, right? We'll go through all the charts and get all the primary keys. The joins is going to be slow, so we can keep two. We'll have to duplicate the indexes, create two more indexes and shard them. Right? You're saying if we had a composite key, right? P1 and P2. Is that what you're saying? Or we had two tables? Oh no, I think you mean two tables.
Yeah, I have two separate tables. Each have a primary key. Somehow you're
Right.
sharding already. The table is sharding to different shard.
Yeah.
Now I want to
Okay, and then
join
you
this two
want
table.
to join. Okay, so it looks like the join is going to happen in memory because we have to retrieve all the records from T1 shard and then T2 shard and then join it in memory. That might be expensive. We may not be able to load all of it.
Yeah, how do you run in parallel? Maybe I have
So,
T1 100 shard, T2 or 1000 shard. One big table, one small table.
We can
different number shard. Now I want to join this two table.
in a query. So we can use the replicas to run in parallel if we can give an offset. Would that make sense? So, for example, we'll use API parallelization. We'll send the first shard.
Let's pick a two table example. Two table have the T1 is primary key integer, T2 primary key also integer. Somehow they have random integer. Now I want to do this. T2 have primary key, right? I want the distance nearby T1. T1 is nearby T2. So any T1 value nearby, but nearby T2 is still sorted already. Maybe, okay, let's say distance equal 6 feet. That's just one table. I want to find that all the point distance equals 6 feet.
Oh, just one table.
The one table distance equals 6 feet. It's still really simple. If two tables, distance equals 6 feet. What I want to do this. I have primary key already sorted already. Another table. I want to be another table. What I want to do. I want to find. How do I find? I want to find. Okay, let's assume I have so many houses in the market. People want to buy and sell house. One table based on housing ID, listing ID. another table based on contain price per square feet. I want to find all the house in this zip code, price per square feet less than 500. Price per square feet less than 500.
Okay.
And in certain zip code is equal Fremont. Yeah.
Okay. So that means
maybe one table is have a sharding based on zip code. One table maybe sharding based on price. Now I want to join them together.
Right. Yeah. So T2 is sharded based on price. First, I find the one. I find the all the property IDs that have price less than 500, and then I also run to find all the zip codes. And I can only think that each of the shards will return the data they found and will merge it in memory. Or we can write it to a temporary table. And merge it.
Well, if T1 is the primary key is the listing ID, then do you want to create an index on zip code or not? Secondary index on zip code or not? If T2 is run the primary key is the price per square feet. So what's the primary key? We can define, okay, T2 have price per square feet is the primary key.
Okay, so this is the primary key, PK, which is the price.
Yeah, T1 maybe the listing ID only based on what the listing time. Table time is a big table, is the listing ID based on listing time. Primary key is listing ID relative to the time, yeah. Yes. Then do you want to create another index based on zip code?
Yeah, zip code is going to be in here.
Secondary index is zip code. Zip code is the secondary index. But we're sharding this. If we're sharding based on primary key, zip code is random.
Yes.
Because we have a secondary index. How is the secondary index works?
Oh, okay. The secondary index is not sharded. Well, currently a new table is created for the secondary index, but we can't shard it because whenever the main table changes, we have to rebuild the secondary index. So that's not scalable. We'll have to duplicate the data. But what do you think? To create it all, we can
you duplicate data. You may create another table called T1S. Create another table called T1S. T1S, the primary key will be second zip code.
Zip code, yeah.
Zip code is the primary key.
The PK. Then that goes into its own shard, and then we can retrieve all the PKs from one shard. But then, yeah, PK and list and ID. We'll get the list and IDs. We can use that to query.
Oh, sometimes people want a more complex query on a price per square feet less than 500. Zip code maybe belong to certain risk code. The 334445555. For the subset prefix zip code is fine. I'm interested in the 3 different locations, 333444555. Also, I don't want in the maybe this price. I want a single floor. I want a single floor. I don't want a 2 floor, single floor. Some property, 2 floor, single floor. I want to be single floor. I want a lot size greater than 6,000 single floor, floor equal 1. Yeah, floor equal 1. And lot size, basically yard size greater than 6,000. And also I want to buy not in big street. I don't want a house in a big street.
Okay, so location.
Location.
residential land.
Yeah.
So
non-busy street. So location equal non-busy street. Yeah, non-busy street.
So if all these properties like location,
yeah,
and floor,
yeah,
is on the T1,
yeah,
then in order to group or search by these fields, we'll need to do a scatter gather on the shard, on all the shards. But unless we also index, we have to secondary index these also. So all the fields on the table will be indexed.
or partitioned.
Or partitioned.
Yeah.
Yes.
If I partition first floor, 1 floor, 2 floor partition, at least 2 categories. Some can be partitioned. The floor I can partition.
Yes, I can partition this.
So people interested in single floor, I can search for single floor partition. Meaning 2 floor, I can 2 floor partition.
I can also partition the location.
Yeah, location we can provide different color, red, yellow, or green. Some location is not good, is red.
Right.
Yeah, partition location.
Okay.
Zip code already location already, but some location, because zip code is already have some location already, but some zip code have some location is better. Within same zip code, some location is better.
Right. Yeah.
So we partition for zip code. Later we sub partition based on different location, like in favor of buyer.
Right. Okay. So partition also it does not duplicate the data, but it groups it.
Yeah.
Into multiple tables.
Multiple table or multiple sub table. Yeah.
Yeah. Okay. And then the yard size we could also partition.
Yard size, maybe create index, secondary index for yard size.
Oh yes, because of the
so many possible range.
Yes. Okay, got it. It's starting to make sense. Yard size index. Yeah. Okay. And then the zip right now, this is a inquiry, right? So I think the index will still work.
Yeah.
And then for the price square foot, this will work because it's on the second table. And then how do we join T1 and T2? Will we have to do it in memory?
We join the memory. We for each partition join, then filter out. Maybe it's hash join. So we discuss so many different problems.
Yeah. Thank you so much for brainstorming through a lot of these things. I think that's very helpful. Okay.
Yeah.
Right. Yeah. Thanks, Xin Liang, right?
Yeah.
Yeah. Okay. Do you mind if I follow you on LinkedIn?
Yeah, no problem. Yeah.
Yeah. Okay. All right. Okay. Thank you then.
You're welcome. Have a nice day.